So as I mentioned, I'm Doug Hohulin, and welcome to the 6G, a vision for 2020 and the 2030s, and talking to this abundance community where sustainable energy, information, communication, and virtual travel is too cheap to meter. And so I'm going to be giving a presentation to Kansas University, and I thought I'd give this presentation also to the Abundance Digital community. So this will be the agenda that we'll be talking to. I'll be giving a presentation for about 25 minutes, or excuse me, 45 minutes, and then after that, we can have any question and answer time till the end of the hour. So I gave my first 5G presentation in a public presentation in 2015, about 5 years ago, and it was at the T-Sensor event where they are focusing on how do I have 1 trillion sensors in the world. And so this came from a slide from the T-Sensor event. The trend is a little bit off of what they were predicting. We're looking at maybe 1 trillion sensors in the 2030 timeframe. But you know, the 5G was just being in development, and then in 2018 it launched. And so I thought this would be a good time to talk or on 6G technology. So just a little bit about myself. I work for Nokia. I came to Nokia through Motorola Networks. In 2011, Nokia acquired Motorola Networks, the cellular arm of the Motorola at the time. And I joined Motorola in 1989. Actually, Nokia acquired Alcatel-Lucent, which is the parent of Bell Labs. They acquired it in 2016. And so I was really proud when Nokia acquired Bell Labs because as an engineer, that's something I really care about. So last year, 6G actually kicked off. And here's a presentation by our Bell Labs, Peter Vetzer. And he talked about last year about how the same year that the transistor was invented by Bell Labs, an engineer, Doug Ring, sketched out a rough design of the cellular telephone standard. The first cellular phone call was made in 1973 from a conversation between Motorola and Bell Labs, which is now kind of part of all the same company. But that was the first introduction to 6G last year. And so 6G, you know, and just this technology in general, we're in this technology of the technology Cambrian explosion of technology. You know, just like 520 million years ago, the Cambrian explosion happened. We are having a similar Cambrian explosion of technology. So I kind of like to think of that we're in a climate change, but also a climate of change. With climate change, COVID, and technology change. And so I'm going to be focusing a little bit, because 6G focuses on this, on communication, biology, energy, transportation. And so it's going to be an exciting time for the 2020s. And the question is, how can we help humanity through this time so we can have abundance for all? So every generation, you know, I work in a lot of change of technology. So when I joined Motorola in the late 1980s, we were having analog 1G technology. Then every years we introduced a new generation of technology. So 5 decades of working in technology, and now we're starting to focus on the 6G. So in the 2030s and that generation of technology. So just a quick overview about the different generations of technology. So when in 1982, when the first cellular telephone systems launched in Chicago, and I think it was Washington, D.C., there were, at the end of that decade, we had 7 million subs around the world. And it's just analog voice. Then 2G came along, and it gave you 64 kilobit of data. And we had 480 million subs in 1999. Then 3G came along, got up to the 3 megabit data speeds, and at the end of that decade, we had 4.6 billion subs. 4G, it's a generation many people are still on right now, and at the end of that decade, in the 2009s, we had 8 million human subs. and a billion, or it first launched in 2009. But at the end of the decade, 2019, we had 8 billion subs and 1.8 billion cellular IoT devices. So now we're in the 5G generation, and that's it has launched in 2018, and we had gives you peak data speeds of over 10 gigabits per second. We're using 100 gigahertz of spectrum that will support tens of billions of devices, 10-year battery life, 1 millisecond latencies for robotics and autonomous vehicle use cases. And now we're starting to think in the technology business, what will 6G look like? And what 6G promises is greater than 100 gigabits peak speeds, using spectrum up to terahertz of spectrum, trillions of devices, 20-year battery life, 10 times faster latency for even more interesting use cases, and such as virtual reality, telepresence, digital twinning, virtual world, biosensors, artificial intelligence, robotics. And if history repeats itself, it's expected to launch in 2028. So, just kind of a background on the electromagnetic spectrum. As an RF engineer, this is something that I look at all the time, and I think people are probably more familiar with, that they use telephones, radios in this frequency band in around 100 megahertz of spectrum, and what each generation expands the amount of spectrum I can use. So I go from 4G technology to 5G technology that gets you up to about 100 gigahertz of spectrum. And now we're looking at up to a terahertz of spectrum being utilized. Side note is that humans, we glow in infrared at 30 terahertz. So just an FYI, and every human basically is generates about 100 watts of power at 30 terahertz. And of course, the sun is up at in sunlight spectrum, and it here on the Earth is about 164 watts of power per meter squared. So, the exciting thing about our technology and working in this technology field is we can get to a billion things very quickly. So when 5G launched in 2018, very few subscribers, but then this year is expected about 60 million 5G devices will be out. It's expected by 2023 that we'll be at 1.4 billion devices, and then by 2025, close to 3 billion devices around the world. A lot of industries, our industry, spending just in the United States about $300 billion to roll out this technology. So right now we're still in the midst of this technology rollout of 5G, but that gives us time to start planning for 5G technology. So again, thinking about the billions of, our cellular world, we think in billions. In the old days, in the 1990s, hundreds of millions with a lot of things. Now billions are what we're more used to. So in 1802 is actually one of the first humans, we reached a billion humans on the planet. 200 years later, we actually had the first billion cell phones. But then things really accelerated, a billion smartphones in 2011, and it just keeps us well. So I started to think about the future of when we'll get billions. For instance, in 2023, a billion 5G users. And then when will we have a billion of other things like virtual reality, telepresence humans, personal digital assistants, and then 6G kind of in the 2032 timeframe. So it's going to be a real exciting time over this next 10 to 20 years of what's going to be available to humanity and how can we help humanity. So one area of helping humanity is, of course, economic development. And as this slide shows, is that we're going to be adding, just in 5G, about 10% or a little bit over 10% of the global GDP. And so as you can see from this curve, it starts up slow. And then after the technology is rolled out, then all of a sudden there's this explosion of economic impact. And then for 5G, by the end of the 2030s, it starts to average out because those use cases that were designed for 5G are optimized and used. So that's why we're starting to look at 6G technology. So what will be the next S curve so we can go to even more economic growth and development. So Nokia just actually reported, did this Nokia 5G readiness report, and we believe that we can get about $8 trillion of economic value added to the economy by 2030. And so this talks about, just basic connectivity. When people ask me, well, what's 5G? Faster data speeds. Well, that's only, zero point 0.6 trillion, only 6.6 trillion. That's a lot of money. But, where the growth is going to come out is with edge infrastructure, artificial intelligence, private networks is really what's going to grow this economic development for 5G technology. So we're in this kind of race to 5G right now, in this exciting time. And, I think there's more of an emphasis now on 5G and now 6G technologies, because what people found is in 4G, when they really, the countries that won in the 4G technology really helped their economic development. So the United States found that, we added $100 billion of economic development because we were one of the first to launch 4G. And so this was shown a couple of years ago, but at the time, 2 years ago, China was in the lead of 5G technology. And the good news is now the U.S. is neck and neck with China. And, but what they found is the countries that led in 5G technology or 4G technology, now 5G technology, had the most economic impact in the world economy. So China, they're focusing. They have their 5-year plan, or their 10-year plans. And here's the next one, China 2025. And one of the aspects of this is 5G, and even now starting to look at 6G in China. So the U.S., a couple of years ago started to see this and said, okay, 5G is coming along, but how do we then focus on 6G going into the future? And so here's a paper that talks about 5G in the front lines of the U.S.-China great power competition, and looking at, okay, now that we're rolling out 5G, what about 6G, and how do we think about 6G? Side note, while there's this competition, I'm concerned about these wars. Either they're hot, cold, cyber, flame, or trade wars. I really like to promote races, like the race to space, race to 5G, autonomous vehicles, ninja warriors, where we share, where these shared races where humanity has a common goal to promote safety, peace, and prosperity for all. So, I think of this race as a race to help people and not to compete. That's my own personal belief. So anyway, in the last couple of years, people have been, starting to think about what does it mean to roll out 6G technology, because it does take 10 years to develop this. And the Alliance for Telecommunication Industry Solutions here in the United States, ADIS, is a standards organization here in North America that has 150 member companies, mainly from the United States, looking at how do we roll out these emerging technologies. And so, the goal is in, the late 2020s into the early 2030s, we'd have 6G technology, we'd have quantum computing, we'd have nanotechnology, personal surfaces, a lot of new technology. And how do you bundle these all together for a 6G technology? So just last week, ADIS actually launched their North America Center Next G Alliance. And all the cellular operator companies are part of this, as well as like Nokia and other infrastructure vendors, companies like Facebook and Microsoft as well. And so the goal of this organization is the 6G National Roadmap that addresses the challenges of a competitive landscape and position North America as a global leader in the development of manufacturing and adopting this technology. So this is the technology we're doing. This is kind of like all the standards body work, and I'm going to be, when I give my presentation at KU, I'll be talking about this in more detail, but it kind of shows you what was required to roll out 5G technology, and kind of knowing the practices and the histories of that, what will take to roll out 6G technology. So again, what is 6G technology? So there's this diagram, we call it the spider diagram, is where you have what is the capacity of 5G, and then what is the multiplier for 6G. So for instance, peak data speeds, you think 5G is fast. The goal is to have peak data speeds of 100 times faster. So you can get peak data rates of 1 terabit per second. The experience data rates of 10 gigabits per second. So, there's a peak data rate, but that's just a lot of times it's marketing. It's really what we experience, and what we can experience is 20 to 100 times with 6G technologies. Reliability, so going from 5 nines reliability to 7 nines of reliability. By the way, your heart, if you live to be 80 years old, you have 9 nines of reliability. So latency for new use cases, and then connectivity density, so you can have more and more devices. As I talk about that, those trillion sensors, or tens of trillions of sensors devices as well. So last year, October 28, 19, the Finnish, the U.S. and Finnish government got together and to strengthen our bilateral technology investment. We started working on 5G and 6G, AI, robotics, and quantum computing. And so that's, the U.S. government's funding this. Expected that there's going to be even more funding coming up in the future, as the governments realize the importance of these technologies for the economy and to help the people. One organization that came out of the Finnish government and universities is the Finnish 6G Flagship. Nokia is part of that, and they started to write white papers on different aspects of 6G technology. Like one, and I'll talk about a few of them. There's 11 white papers. I'm going to highlight 5 of these white papers. And one is how 6G drives the United Nations Sustainable Development Goals. Another one is connectivity in remote areas around the world. Another one is communication, machine learning and 6G. Then there's edge intelligence as well. And then finally, localization and sensing. How do you get to these trillions of sensors, and what interesting use cases can you do with this? So Nokia's a part of that. One area that I'm really proud of is the focus on these United Nations sustainability goals. In 2015, they were announced. There's 16 of them. And, these are how do we help give prosperity and peace to around the world by 2023. So many organizations are looking at how do we map those sustainable development goals. As you can see, here's a drawdown organization that looks at climate, impacts to climate change and how they map to sustainable development goals. So there's organizations looking at this mapping. Here's drawdown again, looking at, here are some of the things like how do I manage refrigerant is a good example, and so forth. By the way, over the from 1751 to 2017, the world has emitted 1.5 trillion tons of CO2. Well, in the next 30 years, we're going to generate an additional 1 trillion tons, and that's if we have no more growth. So drawdown's looking at ways to how do you draw down the gigatons of CO2. We have to change our ways of doing things. So I have a focus on energy, information, and communication. I want it to be too cheap to meter, but the energy needs to be clean. Information, communication as well. So this is how I map to those 17 economic development goals. GSMA, which is our a mobile industry, has written a report and saying how the mobile industry today is impacting those development goals. The sad fact is we're not on track to achieve those development goals. And so the question is what can we do as our industry and other industries to get the world back on track? Is really important. So in this report in 2020, they talk about these IoT connectivity, and we're now up to 12 billion IoT connected devices. You add on top of that the 8 billion cell phones out there, we're about 20 billion IoT devices in the world. And that's expected to grow to the 50 billion. And then the question is, when are we going to get to the trillion of connected devices out there? So Peter Diamandis, in his talk, he wrote a blog in July 2018, talking about the ubiquitous connectivity around the world, and he predicted that in the next 5 to 7 years, that we're going to add 100% connectivity of the global population. Everyone will be connected onto the internet. And I really applaud that goal and that vision. But there are key barriers to access to the internet. One of them is affordability. How can you afford to have this connectivity? Availability. The first thing is, do you have availability? If it's not available, no matter how much you pay for it, how much money you have, you can't afford it. You can't buy it. So at first is availability, then affordability. But after that, there's relevance. Is it relevant in your language and how you interact with that information? And then finally, the readiness, the skills, the awareness, the cultural and social acceptance. One comment is, per my billions talk, that's where I think it's going to be important to have the billion personal digital assistants, because you're going to need that. How can we help people who don't have the technology skills to use the internet properly? So that will be interesting. So the challenge we're having in the internet world is this connectivity divide. Here's a picture that came from one of the talks on the flagship 6G flagship program, and they talked about where is this 4G base stations. And as you can see, in Europe, in the United States, and in China, Japan, you have 4G base stations, but in many places around the world, you don't have that connectivity of high, the 4G, let alone 5G technology. And the sad thing is, especially in developing countries, 87% of people get their connectivity via broadband, via mobile. So, like in Africa, 45% of the connections are 2G devices, which is 64 kilobit data. So think of how your use cases, how efficient you'd be if you had to only operate at 64 kilobits. And then in other parts of the world, 31% use it. So globally, 23% of people still have a mobile connection via 2G, and 25% G. So these developed connections, are very inefficient, and so that's impacting how much economic development and how they can share in this global connectivity to the internet. So while it's good that everyone's connected, if they're connected by a 2G device, that's not as useful, of course. So the updated statistics is 5 billion people right now are active internet users as of July 2020. So 59%. So good news, that's growing. Again, not all connectivity is equal. You have to think of coverage, cost, gigabytes, and then average megabits per second. So the difference between a 2G and a 5G connection is 100,000 times difference. So think of the efficiency you get with a 5G connection. So Peter in 2018, excuse me, wrote, in the next 4 to 7 years, every person on the earth will gain access to the world's information, right? And he asked, what will these 4.2 billion minds discover? What will they consume? And I would argue, though, if they're still stuck on a 2G technology or 3G technology, they are going to be very limited and not get the abundance that our community wants. So this slide I thought was interesting because it shows in 2019 the satellite capacity. I'm really excited about some of the space technology, and I know the abundance community there's a lot of us that are very interested in space. But it shows the capacity through the different satellite systems as of 2019. There's an article because of SpaceX and others that are launching technology that we're going to have 10 times more capacity available by 2024. Interesting in that last year's 6G summit, Dr. Tong of Huawei talked about having 1 petabits per second of capacity available via satellite. So we're starting to look at ways of how do we address people in Africa and on the oceans and in Russia and other places where they don't have the 4G and 5G connectivity. So it's expected to get 500 times more capacity. By the way, this 2 gigabits per second per kilometer that may be available by the end of in the 2020 and 2030s with 6G technology, that's kind of equivalent to 2018 capacity of an LTE system. So it kind of gives you a rough order, because what we're working at 5G and millimeter wave, we can get over a terabit per second per kilometers capacity. So a lot more capacity is available with 5G, and then terrestrial 6G gets you even more capacity. So, I've seen reports that say, well, if you do space technology, you don't need any base stations on the Earth. And no, that's not the case. You can get 1,000 times more capacity with base stations on the Earth versus satellite system. So, but at the same time, where you need coverage, satellites are a good complement to the cellular system to bring again these billions of people connected to the internet. So, just wanted to talk about latency just for a second. We need to start thinking in terms of how long does it take to interact with the internet. And so they have central offices, and then but some applications, you can't, if you have over 20 milliseconds or, up to 100 milliseconds, these applications just don't work. So then they're going into these regional edge areas that get you into the 5 to 20 millisecond range. But then there's the far edge, which is actually, this is where the application's being used. They call it the far edge. Actually, I think of it as the near edge to the end user, but this is terminology they use. But getting to speeds of even like 100 microsecond latency, some of the robotics and other use cases of autonomous vehicles need to have this very low latency technology that's being worked on. Another area of 6G that's being looked at is going from the Internet of Things to the Internet of Intelligent Things. You can put more and more intelligence at the edge, at the device. And then you have the intelligent Internet of Intelligent Things. So how do we make the Internet more intelligent to make it more secure and sustainable? And so these are some of the technologies being worked on both for 5G and for 6G technology. And basically 6G just enhances what 5G currently is deploying. So, they talk about this, 7 levels of different edge technology, where you have everything in the cloud to, everything on the device. And, and how do you, some applications need it all on the device. Like Tesla right now is putting, everything's autonomous within the device, within their car. Other things are putting more and more intelligence into the cloud. And so, we'll see, how each use case uses the different areas of edge intelligence to optimize different use case solutions. At Nokia, I like this slide because it shows that right now we're using about 40 gigabytes per month here in the United States, and it's expected to go up to at least 800 gigabytes per user per month. And then if VR really takes off, you could get into the terabytes per user per month. So this is tremendous opportunity of capacity. And then again, there's the latency considerations, because some like robotics and so forth. In fact, I was on a call, Abundance call the other day, and they were talking about a telejam session. And in that case, the latency needed to be under 20 milliseconds. Because if two musicians are playing in different locations, if they're greater than 20 milliseconds, they actually notice the difference. So you have to look at the use case and what the bandwidth requirements and what the latency requirements are required. So you not only have to think in terms of capacity, but you have to think of latency as well as you're designing the network. So one organization that Nokia is part of, the 5G Alliance for Connected Industry and Automation, where a lot of this robotics and virtual reality is going to really be focused, and you're going to see that being developed. In fact, there's use cases and time-sensitive network there's a real focus on this deployment as well. So one thing that Nokia is doing, and even with 5G technology, is the concept of digitizing a site. We do digitizing site engineering, where we scan in the site either with a drone survey or digital site module libraries. And then what we do is we run the simulation. We actually build the site in the digital world as a digital twin. And then what we do is when we're ready to actually go out and build the site, what we're finding is that our average run rate to build these sites is 30 to 50%. increase. So much more efficient, and the time to build it is a 50%. So, one site visit until the multiple site visits. So using this technology, that's something we're doing with 5G and will only accelerate with 6G. So going back to VR, I have another presentation on virtual reality and when we're going to go get 1 billion VR headsets in 2027. But I like this slide from Alvin Grayland from HTC, where he says, hey, we're at peak screens. If you look at your room right now, I think I looked around and I have 10 different screens in my office here. And, the question is when will we be at peak screens? And eventually you're going to be just at one screen, where smart glasses and contacts, and then eventually is brain-machine interface, so that the screens, the information will go directly to your brain. So interesting time to be alive. So as I mentioned, Nokia is part of the Flagship program, the 6G Flagship program. There's, I think, about 300 different researchers as part of this program. I think it's in 100 different companies and universities working on this technology. So you have here a presentation by our head of our 6G program, Peter Ziegler, and he talks about 6G indicators, values, and performance. And so it kind of highlights where Nokia is focusing on 6G, where ubiquitous compute, it is artificial intelligence, at the cloud and everywhere, precision sensing and actuation, where have again these trillions of sensors. Human-machine interface is an area that we're looking at, and then knowledge systems, again, artificial intelligence, personal digital assistants, some of these, so digitizing the world, and again with autonomous in the factory, in the enterprise, to augment our intelligence. So 6G is a unified experience across the physical, digital, and biological worlds. So it's going to be a really interesting time to see what the next 20 years brings as we cross these barriers of physical, digital, and biological world that we're in. So Nokia wrote this white paper on 6G communication, and IEEE white paper, and talking about this world that we're going to be living in. Talks about use cases, because at the end of the day, it's all about the use case. Some of them that I thought was interesting is, augmented reality for industry. Again, 5G can handle a lot of the use cases, but as we get more and more capacity requirements, that's where you bring 6G in. Telepresence, I think, especially for climate change and climate emergency, that's going to be more and more important. Security and surveillance, again, is very important to have a secure and intelligent network that can handle the security and detect issues beforehand. So zero energy devices, I thought was a kind of an interesting one, where you actually, there's no battery on the device. You actually send energy to the device and it captures that energy, and then it uses that energy as the energy used for the communication. So you don't need a battery with zero energy devices, which I thought was kind of interesting. Biosensors and AI, also, something that 5G can do, of course, but it's going to be more enhanced with 6G technology. So again, I'm very interested in virtual reality and telepresence, and I think this is a great way to minimize our CO2 impact. If in fact, there was a conference that was run in virtual reality, and they had 5,000 people there, and what they found is that they saved about 7.5 million kilograms of carbon dioxide. So next Saturday, there's actually a conference where they may have over 30,000 use in this conference. So instead of having to travel in person, they can do it via virtual reality, saving CO2 gas emissions. So last year, COP25 climate, it cost $100 million. They had 27,000 attendees. So that was 40 million kilograms of carbon dioxide. Rather than doing it, in person, if you could do it remotely and still have all the benefits of the networking effect. So that's what the promise of VR and telepresence is. So, right now our world, with the climate, COVID emergency, that our world economic growth was reduced by 4.5%. Energy consumption was reduced by 5.9%. So we actually had less emissions of 8.6%. So that's the good news. But that's because of all the lockdowns happening. So the question is, how can we have this reduction in emissions, but still have economic growth? And that will be our challenge. So ENERDAT has some really good papers on what's happening in energy and climate and CO2 gas emissions and where the future will be. And is 2020 just a blip of reduction in GDP and a blip in CO2 gas emissions, or can we take the lessons learned and do more telepresence, do more virtual reality, do less traveling, so that we go from having 35 gigatons per year emissions down to 24, and then eventually, as drawdown is trying to get where we have no more incremental emissions, we become carbon neutral society. So that's the goal that we're trying to work on. So just wanted to highlight that our mobile operating organization, we think in 2020, our studies looked at, we added $2 trillion of economic development. But we need to go to a net zero carbon economy. And so what we've calculated is that for every kiloton of carbon dioxide we emit, because of our technology, we actually are saving the world 9 times. We reduce carbon footprint by a factor of 9. So we're excited about what we can bring to the world, and using 5G technology, and then 6G technology will only accelerate that as well. So here's an example of some of the value proposition of 6G technologies. Again, the number of devices greater than 100 billion devices, greater than 100 million, 10 million per square meter, just kilometer, excuse me. Then you have coverage, global coverage, again, for the most vulnerable, latencies of less than a millisecond. So these are the technologies being developed for 6G. So, what we see at Nokia is that 6G will enable a new lifestyle at scale, where, we have the challenges for a sustainable future, and we believe 6G 5G to this decade and 6G next decade can augment our intelligence to create and consume new digital worlds, so it doesn't impact our physical world near as much. So domestic robots, remote and self-driving technology, body monitoring and analytics, analysis are some of the things that are being worked at as part of the 6G program. So at Nokia, we look at these 6 technologies that kind of our focus. There's many others, as I showed from that other slide, but AI, machine learning, air interface technology, new spectrum technology going from 100 gigahertz of spectrum to all the way to 1 terahertz of spectrum. Network as a sensor, how do we handle a trillion sensors out there? The core, the whole network, the infrastructure, how do we interact with that? This extreme connectivity where we can get a terabits per second connectivity. And then, of course, security and trust. How do we make this resilient, available to everyone, and secure and trusted solution? So these are the technologies working at. I'm part of the KU Cybersecurity Board, and T-Mobile, actually, Lyle Pulaski gave this presentation and talked about some of the things T-Mobile is doing. And I got permission to use this slide as well. Again, artificial intelligence in every device, autonomous machines, augment reality, and actually augment reality is going to just, again, this 2 orders of magnitude more capacity is going to be required once augment reality and virtual reality really hits, and then hyperscale, cloud and connectivity. So Lyle put this slide on. He's really big on quantum computing. So he showed these slides. I actually like amazing stories of quantum mechanics. I think that's a good introduction to quantum mechanics, but this paper shows the things that you should know, some of the concepts that you should have at least a a high level understanding as you understand quantum computing and quantum communication. So one area I'm involved in as well is the 5G Automobile Association. They have a roadmap of 2030 roadmap for advanced driving use cases. So we're starting to roll out these use cases, and but in the 2027 timeframe, what you're going to see is more of the high definition sharing, sensor sharing of autonomous vehicles, and dynamic intersection management, dynamic cooperative traffic flows. That's where you're going to see more and more of the 6G use cases. You can build them out in 5G, but then you add to it in 6G technology. So autonomous vehicles are coming out. My own personal prediction, you're going to see some of it by 2025. I mean, already Waymo just announced that they're doing robot taxis. They went to beta where everyone, you can actually sign up and do robot taxis in Arizona. But that'll become more and more prevalent. But I think by the end of this decade, 2029, 2030, you'll really have this, autonomous vehicle technology where you need the capacity of either 5G or definitely 5G and then 6G technologies. So just in closing, there's a lot of universities and academics also investing in looking at 6G technology. Here are a few of them that are being worked on. In fact, next week, there's an Institute of Wireless Internet of Things and a 6G symposium. Bell Labs is speaking at that as well. Other universities are looking at what their role is on 6G technology. So a lot of investment, a lot of planning right now in 6G technology. So it's an exciting time to work in communication technology as we roll out this technology over the next 10 years. So in summary, and then I will open it up to stop the recording and open it up to the group if there's any questions. But the 2020s will be a climate of change. We're in climate change. COVID's changing our world dramatically, and we have all this technology change that's happening, economic change as well. And so communication, biology, energy, transportation can make a big factor for this. Many governments, universities, and companies are starting to plan for 6G as we deploy 5G. 6G use cases align with the United Nations Sustainability Development Goals, which I'm really excited about. 6G use cases can connect the unconnected, which is, again, how do we bring those 2 to 3 billion people in poverty out of poverty? And information and connectivity and energy are the ways to do that. New use cases can drive sustainable and profitable business into the 2030s. So not only are we helping the poorest of the poor, but we also are driving new businesses. Think of the businesses that were developed in the 2010s and what will happen in the 2020s and then into the 2030s. And then finally, we have a climate emergency. If we do things right, I think we can get through this emergency. I'm concerned that if we don't do things right, we actually can, that's where digital twinning and simulations and using information to make good choices. Virtual presence, I want to highlight that again. Just what we're doing right now, I think is really important. And finally, 6G to achieve abundance in the abundance community, where sustainable energy, information, and communication and virtual travel is too cheap to meter. That's where I want to work towards. And so pleased that many of you have joined. It looks like we have about 7 online right now. And I'll turn off the recording, and then we can have any questions, take some time for questions. So if anyone wants to unmute, we can, you're welcome to ask any questions.